Okay, so we are going to talk about a little bit more about relations and functions. So a relation is a set of ordered pairs. What do we mean by ordered pairs? It means the x's and the y's that you plot on a graph. So it could be 1, 3, it could be 0, -5, it could be anything like that as long as one's an x and one's a y. So a special kind of relation is a function. So a function is a whole bunch of ordered pairs put together, and then when you look at them, you see that you have no repeating x values in any of the points. So let's look at one of these. We've got one of these is a function and one is not. So I'm going to look at this. We got in our x values, we have 1, 4, -2, and 3. So none of those x values are repeating. So yes, that is a function. But let's look at the next one. You've got 0, 1, 3, and another 1. So because there's 2 1s in this list, it is not a function at all. So let's go look at some other ways to tell. So if you get the vertical line test, you can go and draw a line through any point in the graph, and it will only cross the graph once. Now these are just dots, so it doesn't really count. I mean, it does count, but it's kind of easy to tell because it's only crossing one dot at a time. And with this one, it is also just dots, but you can see it's not a function because this vertical line is crossing 2 dots. And this vertical line is also crossing 2 dots. In Algebra 2, most of our graphs are going to be connected. Anyway, we're not going to have a lot of dots, so they're going to look like this. So you've got to be able to draw a vertical line through any point in the graph. But nope, can't do it. There's one there and there's one there, and I don't know how that disappeared, but it did. All right, let's go on and look at something else. So there's some more stuff about domain and range that we can talk about. Like I said, our graphs are going to be, from now on, connected. So they're going to be a straight line and a straight line. This is a function, because if I draw a vertical line anywhere, it's going to cross just one time through the graph. But we don't list our domain and range as points anymore. We talk about what is allowed to be. Okay, what can it be? Well, if you look at domain is all your x values that go from left to right. So if you're able to draw all your x values, your graph is going to keep going left and it's going to keep going right. So your domain is all real numbers. Same thing with it going up and down. There's your range going up and going down. And look, it's going to keep going up, it's going to keep going down. So your range, again, is all real numbers. Let's go and try looking at another kind. Oh, we need to talk about interval notation. So interval notation is how we describe it in math language. So instead of me saying all real numbers, I don't know why this is erasing, but instead of me saying all real numbers, we have to write it in a notation of an interval. And we're going to say it goes between negative infinity to positive infinity. Think about your lines. This is negative infinity, right? This would be 0. This would be positive infinity. It just keeps going and going and going. That's all your real numbers that are between the two infinities, right? So we're going to say negative infinity is my smallest value. Positive infinity is my largest value. And if I'm saying domain, I'm talking about x's. All of the x's are less than infinity, and every number in the world is greater than negative infinity. So that's how we notate that for those. Let's say we're talking about, oh, x is greater than 2. Okay, we make our notation, draw these brackets to show that we're talking about an interval. And we're going to start with our smallest number, 2, because we're looking for numbers that are greater than 2. So our smallest number is 2. It can be anything bigger than 2. So it's going to be all the way up to infinity. And we're talking about x. Now the alligator mouth is opening up toward the x, so it's going to open up toward the x this way. And then we're going to draw it that way. So all of these numbers are less than infinity. And why is this deleting? And all of these numbers are greater than 2. All right, let's play around with this for a minute. But before we do that, I want you to reset your calculator. You're going to press your second button. You're going to hit your plus sign. Then you're going to press the number 712. It's going to reset it. And then remember to go back and reset your mode so that you can speak in imaginary numbers. So you go down, real is probably highlighted. You want it to be A plus BI. Highlight that, hit enter, and now your calculator is ready for imaginary numbers. And then one more thing, when you graph, if you can't see your graph, oh, I can't see my graph, zoom 4. Okay, that might help you see it a little bit closer. Zoom 6 helps you see the whole thing. It's going to be a lot better that way. All right, so let's take this function, 2x plus y equals 3. All right, in order for us to be able to put this in our calculator and graph it, we could plot points on a table like we did in Algebra 1, but we don't want to spend that much time doing that anymore. So we are going to go and, hold on. Okay, so I'm going to let you solve for y before we put it in our calculator. So go ahead and hit pause and solve for y. Okay, so I solved for y, and I'm going to put that in the calculator. So you're going to solve for y, then you go and press the y equals button, and then you put in negative 2x plus 3. Don't know why it's doing this. All right. So you're just going to put in negative 2x plus 3. And you'll go and hit your second button. And you want to go to your table, which I think is your graph button, which is up on the right. So once you go in your table, go ahead and fill in some points just in case you want to graph it. So we're going to fill in for negative 2. I mean, you just look at your table is really what you're doing, and you're going to take this table and plot some points. I'm going to fill in my table real quick, and then we'll plot points, but your table is already filled in. Okay, so I filled in my table that you already have on your calculator screen. So let's go and plot some of these points. Negative 2, 7, 1, 2, 3, 4, 7 is right there. Negative 1, 5. Now you don't really have to plot the points if you know how to graph using your y-intercept. All right, I'm not going to test you on this, but it makes life a lot easier. And your slope is negative 2. All right, you're going to just go ahead and fill in because we're counting rise over run, rise down, run 1. So we're just going to fill in these points, or you can use your table. It's up to you because it's not about finding the slope right now. I just want to know that you can see the graph. All right, so we're trying to find the range when the domain is negative 2, negative 1, 0, 1, and 2. So we are listing points now. Now look, all you have to do is look in your table. There's your range. Oh my gosh, why does it keep doing that? All right, so your range is going to be, what is that? Negative 7, negative 5. I'm sorry, is that negative 5? No, it's positive 7, sorry. 7, 5, there's no negative there. 3, 1, and negative 1. And there you go. Took your range, or you took your domain, and you wrote out your y values, which are your range. All right, let's go on to another one. I'm going to drop this stylus because it's not working. All right, plug this in your calculator. So you go y equals, that's a button you push. Otherwise, you're not going to get a graph. You're going to do x squared. Now, x squared is x. You can either hit the x squared button, or you can do this little button that is kind of on the right-hand side of your calculator. That means x squared. And then you're going to go out of it. You've got to push your arrow button if you're in a new calculator. Okay, and then go -3. Otherwise, everything stays in the exponent. Take a minute to do that and look at your graph. We're not going to worry about the table too much. We're just going to look at our graph. Okay, so this is what your graph should look like. If it doesn't look like that, try hitting zoom 6 so you get a standard window. Now let's talk about the domain. Now if we were looking at just the x values, if you want to look in your table, go ahead. Your x values go on forever. They keep going on down to -5, -6, -7. You could go on to negative infinity. So that's where we're going to start. negative infinity. And if you looked at your positive side of your x values, they're going to keep going on to positive infinity, because ultimately this graph is going to continue going toward the left. It's going to continue going toward the right. Even though it looks like we're pointing up, the x values will still go to the right. So we're talking about domain, it's going to be x. Then we do a less than sign here and a less than sign here, and we are done with our domain. So that means all reals. Now range is not so simple. If you look at your graph, and mine's a little off, this is your lowest y. Okay, what is that number? Well, -1, -2, -3 is your lowest y. So we're going to write -3. We're talking about our y's, so let's just put in our symbols for in between. And then look at this, it just keeps going and going up, right? Because your graph is going to keep going up. So it goes up to infinity. And that's your range. Let's try another one. Okay, if you have a new calculator, you need to put fractions in your calculator. Try pressing the alpha and then press the y equals, and it's going to give you a nice little fraction box that you can put things in. So this next one has a fraction. So press your y equals, that's for this part. Then to make a fraction, you press alpha and then y equals again. So you should get something that looks like this. And you're going to put in 2 and x minus 5. Now, if you are not don't have a new calculator, you're going to have to put in your calculator y equals, you can put the 2 in, then press the division sign that looks like that, and then you're going to put in parentheses x minus 5. You got to keep your denominator together. All right, I'm going to go ahead and graph it. I'll give you a minute to do that. Okay, so if you look at your graph, it does look like this, and that's okay. All right, that's what it's supposed to look like. So let's talk about the domain. Okay, so what is your domain? Well, the domain, let's look. It keeps going from the left, so it does start at negative infinity. All right, and it keeps going, but it kind of turns right here, right about when it's going to hit 5. So we're not going to get too complicated with this, so I'm not going to teach you that hard stuff. We're going to say that the domain is all reals, but x is not equal to 5. If you go in your table, in your calculator, you're going to go to 5, and you should get a nice little error sign that says, nope, can't happen, because it's turning before it gets to 5. Same thing here, it's going down here along 5, and then it turns on the y. We're going to talk about that. So the range is not y, the range is r. So range is going to be, well, look, it could be anything, right? It goes all the way up to infinity. It goes down to infinity. So basically, it is all reals. But there's one thing it cannot be. Look where it's turning. It is turning, well, it's scooting along here, and then it turns again right before it hits this line right here, the x-axis. So what is that number that represents that? Well, if we were to count, this would be like -2, right, for your y. This is -1. This line looks to be 0. This is 1. This is 2. So it looks like y is not allowed to be 0. And that's really all you have to write for the domain and range like that. Okay, I'm going to go to another video so that we can practice some new things, and then I'm going to go over the homework on there.